for this, for anyone else that's, again, this class looks like we have everybody here, but for some of the other classes. So if you're told to graph a rational function like 21 or 22, the very first thing I would start with is finding those asymptotes, which it's funny, that's f and g. So I'm going to go ahead and write that down. Might as well write down my answers here. Let's put them right here, actually. F asks for state the equation of the vertical asymptote. The vertical asymptote is whatever is going to make you divide by 0, which in this case, I would say that x cannot be -2, right? That's what would make it divide by 0. But the equation of that asymptote then is x equals -2, the number that I can't plug in for x. And then I could graph that. -2 is right here. G asks for any horizontal asymptotes. That's always this value right here. Y is equal to 3, the k value. There's my two asymptotes. That might be enough for you to be able to figure out which of the options on the multiple choice test is correct. But often there might be one that's like here and here, and another one where they're in the opposite quadrants. So you're probably going to have to plug in at least 1 point. So if I plug in 1 point, let's plug in -3. 1 over -3 plus 2 plus 3. -3 plus 2 is -1. 1 over -1 plus 3. 1 over -1 is just -1 plus 3, which is 2. I put in -3, I got out 2, that's this point right here. And that's enough for me to know, oh, here's my graph. You would be welcome to plug in more points, -4, -5, -6, but we don't really need to here. If I know that, okay, it's in this quadrant, going next to the asymptotes, that's going to be enough. I could probably even guess where the other one's going to be, but let's go ahead and plug in a point there too. Let's plug in -1, just to the right of our asymptote. So if I do that, if I plug in -1, 1 over -1 plus 2 plus 3. -1 plus 2 is 1. 1 over 1 plus 3. 1 plus 3 would be 4. Sorry about that, guys. All right, so we've got this one. We plugged in -1. We plugged in -1. We got out 4. That's right there. We can draw the rest of our graph in. Does anyone have questions about graphing? Now, just so you know, on the test, it's multiple choice. So you're going to get something that looks like this. Which of these 4 options could be the correct one? Is it a graph that looks like this? Is it a graph that looks like this? Is it a graph that looks like this? Or is it a graph that looks like this? So which, if this is A, B, C, and D, which of those matches what we just graphed? Does everybody see that? I know that pink is really hard to view up there on the screen, but does that make sense to everybody how you would pick out the correct answer? Even if there wasn't like real precise points. You could still tell where should those asymptotes be, where should the graph kind of show up. So now that we've got our actual graph, let's answer the rest of the questions. B and C are probably the hardest part. There's going to be a question that asks for this though. Letter B says find the y-intercept. Y-intercept means make x 0. So 1 over 0 plus 2 plus 3. 1/2 plus 3 would be, you could get a an improper fraction, 7 over 2, or 3.5. And if we look, 1, 2, 3.5, that looks right for my y-intercept. For letter C, when it asks you for the x-intercept, this requires a little bit more work. For the x-intercept, I could put in 0 for y, 0 equals 1 over x plus 2 plus 3. And then solve that, subtract 3 from both sides. Negative 3 equals 1 over x plus 2. Make it negative 3 over 1, and then do your cross multiplication. Negative 3 times x plus 2 equals 1 times 1. I still have some people, I forget if there's anyone in this class, but still have some people that are trying to make this into a fraction. Remember, the whole point of cross multiplication is so that you don't have fractions. You instead have an equation that you can solve. So let's solve this. Do the distributive property. Negative 3x minus 6. A lot of people are forgetting to do that second piece of the distributive property when they do cross multiplication. Equals 1. We could add 7 to both sides. Negative 3x equals 7 plus, I got ahead of myself, 6. Add 6 to both sides. I was getting to the actual answer there. 1 plus 6 makes 7. And then we could divide by 3. Divide by negative 3. And get that our x-intercept is negative 7/3, or what, negative 2.333 going on forever. Which, again, negative 1, negative 2, negative, right in there between negative 2 and negative 3 is our x-intercept. If they want these as points, it might be 0, 3.5 for the y-intercept, and negative 7 over 3, comma 0 for the y-intercept, or vice, like the decimals or fractions. That's the one problem with multiple choice, right? They might give you decimals and you have it written as fractions. You need to be able to tell which one's which and that they are the same. But there's ABC. Okay, here comes the interesting part. D. State the domain. These are going to be out of order, right? We already did F and G. D says state the domain. Your domain is directly linked to your vertical asymptote. So if my vertical asymptote was negative 2, my domain is negative infinity to negative 2, and then negative 2 to infinity. And similarly, my range is going to be directly linked to my horizontal asymptote. If my horizontal asymptote is 3, my range is negative infinity to 3, and then 3 to infinity. So we've got D, E, F, G. Now let's skip down here. And let's talk about H. H is where it's increasing. This graph doesn't increase at all. If I'm reading it from left to right, it's going down, and then it breaks, and then it goes down again. So I'm going to put none. There is no increasing part. I, where is it decreasing? That's the same as the domain. Negative infinity to -2, -2 to infinity. It's decreasing the whole time, except for the break in the graph at the vertical asymptote. J, where is it greater than 0? It's greater than 0 everywhere it's above the x-axis, which means almost the entire graph. It is above the x-axis here and here, which means negative infinity to the x-intercept, negative infinity to -7/3. And then from the vertical asymptote to infinity, which means the only place where it's below is this little section right here, which goes down to infinity forever, but as far as the x values, it's only the missing piece from J. It is -7/3 to -2. Does that make sense to everybody? Just this little piece from the x-intercept to the asymptote is below the x-axis. Does anyone have questions on that one? All right, so that's everything except, let's get a little bit more practice in. I'm not going to do 22. 22 is exactly the same as 21. 23 and 24 is focused specifically on horizontal and vertical asymptotes in domain and range. So let's talk about those. I'm going to give you 2 minutes to come up with the horizontal and vertical asymptotes for 23 and 24, and then the domain and range for each of those. That should be real fast. Go ahead and try it. 23 and 24. Sign out and take a pass. All right, let's go over those. Oh. So this, most of what just got passed back was late work, I think, stuff that had been turned in later on, you hopefully. If you didn't get something back right now, it's because you got it back earlier. If you feel like you're missing something, I do still have a small stack of stuff that got turned in last week that I'm grading, and a small stack that I just hadn't sorted through that I graded like on Wednesday, Thursday, Friday of last week. Okay? So if you're worried that you want to make sure that I have something because you haven't seen it in the grade book, ask me today, and I'll be happy to check for you. Real fast though, on 23, let's get those horizontal and vertical asymptotes. Let's start with the, well, either one. Let's start with let's start with the vertical one. Sorry, going back and forth because of what I did with the other class. So let's start with the vertical asymptote. Alejandro, what'd you get for the vertical asymptote for 23? Okay, so what would make us divide by 0 here? What? So 5 plus 5 is okay. What's the opposite of 5? Right, so our vertical asymptote is x equals negative 5 because I can't plug negative 5 in. The horizontal asymptote. Nick, what do you think? What's the horizontal asymptote? Negative 2. Y equals negative 2. Now, on the test, you can be sure if they ask you for the horizontal asymptote and the answer is supposed to be negative 2, you can be sure that they're going to list x equals negative 2 also. Does that make sense? You have to know which one's which. Know that a horizontal asymptote, the k value is y equals, vertical is x equals. Now that we have that, let's get the domain and range. The domain is directly linked to the vertical asymptote. Kathy, can you tell us what the domain would be if I can't have negative 5? So let me go ahead and show this one again so that everybody gets the idea, and then Kathy, I'll have you do the range with the horizontal one. So if my vertical asymptote is negative 5, that's the one x value I can't have. My domain is negative infinity to negative 5, and then negative 5 to infinity. It's everything except for negative 5. So Kathy, what would my range be if I can't have y be negative 2? So do the negative infinity first to negative 2, because we always go smallest to biggest. And then, yeah, negative 2 to infinity again. Does that make sense? So everything except for that negative 2 value. Let's do 24, vertical asymptote. Harshram, what's the vertical asymptote for number 24? Say that again. I feel like I'm mishearing you. Let me come a little bit closer and make sure I'm getting what you're saying. So what's the vertical asymptote? Yes, that's right. So x equals 4. That's the one value we can't put in for x. Let's get the horizontal asymptote. Nathan S., what's the horizontal asymptote? Positive 1. Y equals 1. Now that we've got those, we can get the domain. Ethan Rocca, what's the domain? Yep. There we go. Everything except for 4. And then, Alyssa, what's the range? All right. Is everybody okay with finding that? So take your time on the test. Those should be quick questions, though. If they ask you for horizontal and vertical asymptotes, there you go. If they ask you for domain and range for a graph like this, there we go.